Hi, my name is Jason Olson. The intent of this video is to help us understand about why a coil of a contactor will burn out if the armature is jammed in the open position. So we have to look at some of the properties of that contactor and the properties of an AC circuit to understand that. So my contactor, I have an E-frame, also known as the core, and an armature. I have a coil wrapped around that E-frame, and the whole intent of that coil is when I energize it to create an electromagnetic field that will close this armature and close a set of contacts, therefore allowing my motor to run. So we have to look at the length of the magnetic path of this armature. So when I energize this coil, we know that when I energize a coil, I'm going to create an electromagnet. And right now, the magnetic path is looking like this. It is through the E-frame, through the core. What is also through is that air gap. So we look at the property of inductance within this circuit. And we know that inductance is equal to the number of turns, the permeability of the core, the area of the core, and the length of the core. So right now, when this coil is initially energized, I have an increased length in my core because it includes that air gap. Therefore, I will have a decreased value of inductance. We look at the properties of inductive reactance and how that is limiting current. And we know that XL is based on 2 pi FL. So if I have a decreased inductive value, I will have a decreased inductive reactance. So if we look at how this is affecting current, I look at Ohm's law that said it was directly proportional with voltage and its opposition to current flow, in this case, inductive reactance. So if I have a decreased inductive reactance, I will have an increased current in that armature. So at a point of energization, we can look at this waveform and see this is when current is rising. And if that armature never moves, that current will continue to rise until something happens. Quite likely your coil will burn out. Well, why does the coil burn out? We look at one of the properties of this circuit that is a resistive value. And we look at the heat or the power of that circuit. That resistive value is based on the wire. So if I have an exponential increase in current, I will have an exponential increase in power or dissipated heat. That dissipated heat is going to burn that coil out. I hope this has helped. We'll see you next time.